So now I will go ahead and I will start with the second lecture, and that is going to be non-probability sampling. And in this, the first one that I'm going to go ahead and take will be convenience sampling. सबसे easy word ही suggest कर रहा है what it is. So when I talk about convenience sampling, what does it mean? Convenience means you are choosing at your convenience. Mane, like for example, I gave you an example yesterday also. When I want to do a research and I directly go to my relatives and I ask them, please fill this Google form for me. And I just use that to do the analysis. It is at my convenience. Or let's say that, I want to understand the behavior of people shopping, right? I go to my nearest mall and I just go ahead and from there, I look at the behavior, right? I just ask people to fill the form. Then I'm just going to my nearest mall now. I am not going to any other mall. I am not going to any other place. So when you go ahead and when you have taken your convenience in doing the sampling, you have considered your ease in carrying out the sampling, that is called convenience sampling. Why is it called convenience? Because the researcher is considering his or her ease while getting in touch with the subjects, right? So we can go ahead and say that this is at the ease of the researcher, right? And he gets in touch with the subjects at his convenience. And you can just quote an example like going to the mall. I have seen many people doing this. Many of my contacts on LinkedIn, they just post their Google form on LinkedIn and ask people to fill it. But that is at convenience, right? So convenience sampling is done at your ease. Now the second one is called judgmental sampling, and it is also known as purposive sampling. When I talk about, देखो, word से ही हमेशा याद रखनी है चीजें. So judgmental comes from the word judgment. Purposive comes from the word purpose. मतलब क्या? मतलब you are going ahead and you are doing sampling at your discretion. Just for example, let's say that, I want to understand how, how many people out of economic honors will go for a master's degree and how many people will go for a job. I am interested in only those students who want to go for a master's degree. What will I do? I will go ahead and I will put one basic question first, that are you interested in studying masters? बस इतना question पूछ लो. People who say no, automatically I will eliminate them from my sample. क्योंकि मेरे को उनको पढ़ना ही नहीं है. I am only interested in understanding the behavior of people who want to go ahead and who want to do masters. Otherwise, I'm not interested. So this itself becomes judgment. This itself becomes my purpose. My purpose is to look for people who want to do masters. So I eliminate the people who don't want to do masters out of my sample, right? So we can say that in this case, you are forming the sample at your discretion. Same, just I want to study how people survive who are below the poverty line. So I ask the income level of people. Now, people whose income is below poverty line, I will keep them. But whose income is above poverty line, I will eliminate them. That will not be part of my sample. So when I have a purpose in mind and I create a sample according to the purpose, that is called purposive sampling. Now come to the third one, beta. So this is snowball sampling. Okay, now snowball sampling is basically when your subjects are difficult to trace. ठीक है जी? Take an example. Suppose, let's take the previous example only first. Let's say I wanted to study people who are below poverty line. Now, there may be people who do not want to go ahead and disclose their income. So even though they will be below poverty line, but because they did not disclose their income, I would be having only a sample of people who disclosed their income. Okay. So which means that my subjects are difficult to trace. My sample will, यहाँ पे randomization नहीं हो पा रही, because जो लोग बता ही नहीं रहे कि उनकी सैलरी कितनी है, उनको मैं अपने sample में randomly include नहीं कर पा रही. I'm not able to include them in my sample. So when I talk about snowball sampling, it is when your subjects are difficult to trace. Let us take one more example. Let's say research on HIV/AIDS. Not all people who have this will tell whether they have this disease or not, right? I will have some volunteers telling that, you know, these are the symptoms, this is how it happens, etc. Right? So only people who volunteer to be part of my research can be included in the sample. Because not all people are part of my sample, only volunteers are part of my sample, automatically randomization cannot take place, and therefore it is called snowball sampling. So you can keep writing some examples here, beta. So this can be when people don't disclose their income. So only volunteers are part of sample. Now come to the last one, fourth one. This is called as quota sampling. Now, many students in exam, they will get confused between quota sampling and between cluster and stratified. ये तीनों बहुत similar लगते हैं. तो पहले तो you should be very clear that quota sampling is non-probabilistic. मतलब किसी तरीके से मैं randomization नहीं कर रही हूँ. Whereas stratified and cluster are probabilistic, which means I was doing randomization in some way. Now just think about it. Quota sampling is when you have some group in mind. मतलब एक strata type ही बना रहे हो, एक group के साथ ही deal कर रहे हो, but you're not randomizing, right? So for example, I have a group in mind that I want to understand how many people between the age of 15 to 20 smoke. So I have a particular group that I want to deal with. And that is the age group of 15 to 20 plus they should be smoking. I have a quota in mind. Quota means I have a particular group in mind and I just want to take sample of those group, only those people, right? So when you do sampling on preset standard, that means you do sampling only on what you have in mind. Like for example, 15 to 20 age group of people who smoke. I have a particular subgroup in mind now, then that becomes quota sampling. Again, I am not doing randomization here. That is why it is non-probabilistic in nature. So I hope this is clear to you. This can come as MCQ questions very well, beta. you should be aware of probabilistic and non-probabilistic sampling methods, and उसके अंदर चारों methods जानने बहुत ही जरूरी है. Now, today I want to talk about an important topic, and that is pictorial and tabular methods. Pictorial and tabular methods. But before I do that, let us keep some symbols into mind. So, beta, first symbol. The sample size is denoted by n. So, whenever you collect a sample, that sample size is denoted by n. Second, this will be useful in hypothesis testing. That suppose you collect 2 samples. Let's say that I have this classroom of 100 students. I collect a 10 student sample. And then, I maybe want to do one more research and I want to do one more sample. So I collect a 12 student sample. So from the same population, you are collecting 2 samples. So when you collect 2 samples, then you will use n and m. So I will have my first sample size is 10 and second as 12. So 2 samples denote their size by n and m. Third, denote a variable by x, right? And the observations by x1, x2, and so on till xn. Okay. So I can say, suppose x is age of these students. So x1 represents age of first student. X2 represents age of second student. And so on. So you represent x1, x2 till xn as the ages of the different students. I hope this is clear. Now, let us go to the first technique, beta, and this is known as stem and leaf display. Okay. What is stem and leaf display? It is a technique that is used to go ahead and classify the variables. The variables can be discrete or continuous. The aim is to somehow show them in a more better way, in a more enhanced way, right? So we can say that stem and leaf display is a technique to classify discrete or continuous variables. Now try to learn how I will do this. So what I will do is, there are multiple steps in this. The first step is to go ahead and select one or more leading digits. So leading digit selection. I will give you an example, don't worry. The first step is to go ahead and select a leading digit. Whatever leading digit you will select, that will be called as the stem, right? But secondly, you will select what is called as the trailing digits. The trailing digits will become the leaf. Okay. Okay, beta. So then you will have the trailing digits, and the trailing digits will be called as leaf. Third, after you have selected what your stem and leaf will be, you will go ahead and put stem in vertical column. right? And you will record leaf corresponding to stem. अब समझो क्या किया मैंने. I am saying go ahead and select stem. But I am explaining, don't worry. अभी तो I have not started. देखो, I am saying that I am selecting stem and leaves for the data. तो देखो ध्यान से. Suppose you are given this data set 23, 58. Randomly I'm writing 62, 62, 63, 65, 67, 68, 71, 72. एक और 71 ले लेते हैं. 71, 72, 80, 82, 84, 84. ऐसा कुछ दिया हुआ suppose. Now, what am I saying? I am saying leading digit selection becomes the stem. Leading digit माने क्या होता है? The 10th digit. That will come out as your stem. So what will I write? I will have my leading digit. And that will be 2, 5, 6. बेटा एक ही बारी 6 लिखोगे, बार बार नहीं लिखना है, ठीक है? 2, 5, 6, 7 and 8. These are my leading digits. Leading digits माने ये हो गया tens and ये हो गया ones. Tens, ones. Tens, ones. जो भी tens की place पे आ रहा है, that is your leading digit. ठीक है बेटा? अब क्या करना है ना? I know that I have digits from 2 to 8. So sometimes what some books will do now, that they will fill in this blank also. Matlab, they will write digits in between also. So they will go ahead and they will write 3 also and 4 also. ये हो गए हमारे stems. This becomes my stem. Now what I will do is, corresponding to the stem, it says the second step is to go ahead and get the trailing digits and those will become your leaves. So beta leaf ho gayi anything that comes in the ones position. So here I will go ahead and I will say leaf. Leaf क्या हो गई? 2 से related तो सिर्फ 3 आ रहा है, तो 2 की leaf हो गई 3. 3 और 4 से related कोई leaf नहीं है, leave it blank. 5 से related leaf है 8, put 8 here. ठीक है जी? Then 6 से related leaf हो गई 2, 2, 3, 5, 7 and 8. So put these leaves 2, 2, 3, 5, 7 and 8. ये हो गई 6 से related leaves. Then बेटा 7 से related हो गई 1, 1, 2. So put here 1, 1, 2. ठीक है? 8 से related 0. You have to write 0 also. Because 0 को blank अगर समझोगे तो गलत होगा. Blank सिर्फ तब आएगा अगर वो number exist नहीं करता. So 0 is also a digit, right? So I will start with 0 beta. 0, 2, 4 and 4. So this is what a stem and leaf is. What have I done? I have written all stem in the vertical column and corresponding to each stem, I have recorded the leaf. Okay? That is called stem and leaf. Now, why do we want to do this? Iska kya meaning hai? Why are we doing this? Why are we representing it? But one thing, at any point of time, from stem and leaf, you can go back to the number. जैसे मुझे पता है मेरा number 23 रहा होगा, फिर 58 रहा होगा, फिर 62 रहा होगा, फिर 62 रहा होगा, 63 रहा होगा. So from stem and leaf, I can go back to my original numbers also. That is not difficult. ठीक है जी? So first of all, that's the thing. That typically ये एक better representation दे रहा है और कभी भी इससे हम वापस डेटा पर जा ही सकते हैं. But the important part is that it helps you identify gaps in the data. For example, I know that there is data missing in 30s and 40s. There is no one in the 30s and 40s, right? Similarly, it helps you understand whether your data is symmetric or not. For example, I know कि highest जो frequency के numbers हैं, they lie between the 60s क्योंकि यहाँ पे इतने सारे numbers form हो रहे हैं. So it helps me understand whether my data is equally spread or there is some, some class in which I have a very high number of data points. जैसे यहाँ पे 62, 62, 63. तो 60s में बहुत सारे numbers हो सकते हैं. And इसी से I want to come to my next point, that it helps me understand peaks in the data. So I know because 60s में इतने सारे numbers हैं, this must be the peak. जो 60s वाली line होगी उसमें frequency बहुत high है और बाकियों की frequency comparatively कम है. So I understand where I am attaining this peak, right? So how many peaks are there? यहाँ पे बहुत सारे numbers हैं. 60s की frequency बहुत high है. 70s और 80s की comparatively बाकियों से ज़्यादा high है. So I can know the number and location of peaks. And at last, you can know the presence of outliers also. So imagine something like this. Suppose I tell you that here I have 9, 10, 11, 12, 13, 14, 15, 16. यहाँ पे कोई भी data नहीं है. And all of a sudden, I had a number 161. यहाँ पर आ रहा था number. I clearly know that this is an outlier to my data set. क्योंकि ये एक अकेला नंबर है जो बाकी डेटा सेट से बहुत दूर है और जो कहीं से भी किसी और से कनेक्टेड नहीं है, right? Maybe even I can think that 23 is an outlier because all other numbers are between 50s to 80s. So it helps me understand whether my data has an outlier or not. Okay, so that's the first technique, which is known as stem and leaf. Let us go to the second technique, beta. And the second technique is called as frequency tables. So let's take some data set. Let's say I have age of students given to me. And this age of student is given like this: 5, 7, 5, 9, 11, 7, 7, 6, 9, 9, 9, 10, 12. I'm just randomly taking some numbers, 12 and 7. This is the data given to you. I can go ahead and I can represent this data in the form of a table. So what can I say? I can say that, okay, let's take age here and let's take frequency here. And now I will go ahead and I will start mapping this. So I can say, okay, the lowest age that I have is 5. How many people have an age of 5? 1, 2, and that's it. So the frequency is 2. Then the second is 6. How many have 6? Just 1. Then I have 7. How many have 7? 1, 2, 3, and 4. Then I have 8. How many have 8? 0. Then I have 9. How many have 9? 1, 2, 3, 4. Then I have 10, which has 1. 11, which is 1. And finally 12, which is 2. So I have gone ahead and I have mapped age to frequency, right? When I go ahead and I do that, that is called as a frequency table. Is this clear? So frequency table is very easy to make. You just have an age mapped to frequency. Now, what can be done is that you can go ahead and you can make something which is known as a dot plot from it. Dot plot is just representation of frequency table in terms of a diagrammatic approach, right? Diagrammatic approach is where you go ahead and you show these frequencies in terms of a dot format. So let's see this. So let's say that I am again going to go ahead and write these only, beta. So I have 5, 6, 7, 8, 9, 10, 11, and 12. Now with 5, I have 2. So I will write 2 dots. 1, just leave a gap also here. 1 and 2. With 6, I have 1 dot. So 1. With 7, I have 4 dots. So 1, 2, 3, and 4. With 8, I have 0 dots. So no dot. With 9, I have 4 dots. Right? With 10, I have 1. 11, I have 1. And 12, I have 2. So when you go ahead and you show them like this in a dot process, that is called as a dot.